And although most of you have seen sigma notation, it's still somewhat mysterious, right? But you don't have to be afraid of sigma notation because it's really just a shorthand for other things. So let me explain by an example. Suppose you have I equals to 1 through n of I squared. What does this mean? It means that you start from this lower number, 1, and you keep increasing by 1, and then until you reach n, you keep plugging into this function here, and it generates numbers, right? So when 1 goes in here, it's 1 squared. The next number is 2. 2 goes in here is 2 squared. The next number is 3. 3 goes in there, 3 squared. And then you keep doing this until you reach n, in which case you get n squared because you plugged in n into I squared, right? And then this sigma here, this is Greek letter S. Right? Greeks have their own alphabet, right? And it's letter S. And why are they using S? S for what? Summation, right? So summation, meaning you add them up, that's what this means, okay? In other words, this left side is a shorthand for the more complex looking thing on the right side. That's all it is, right? Now, we are not going to be doing products, but to give you an idea, if you had pi instead, this will be like 1 squared times 2 squared times 3 squared all the way up to n squared, because pi, this is capital Pi, Greek letter P. P for what? Product. Yeah. So that's what it is, right? Okay. So why do we want that? Well, you can say that this is mathematicians' way of going green, right? Rather than writing this much to use more paper, we save paper by writing this much. It takes less space, right? Also, it takes less time to write this than to write the right side, so it's faster. And thirdly, it also addresses the problem of ambiguity when you write this dot 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 notation. So for that, let me explain. Let's say you have 2 plus 3 plus dot 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 until 13. Now, usually people will see this and say, oh, so you're adding all the numbers between 2 to 13. But some mathematicians will look at this and say, do you mean you add 2 plus 3 plus 5 plus 7 plus 11 plus 13? Where are these numbers coming from? Those are?
The odd numbers.
No, not the odd numbers. The prime numbers, right. So for people who know all the prime numbers, this might mean to them like adding all the prime numbers between 2 to 13. So it has two different ways of interpretation if you write it like this. However, if you actually wrote down sigma I from 2 to 13 of I, then there's no ambiguity here. This means literally all the numbers between 2 to 13, all the integers between 2 to 13 will be added. So that's why you also want to use the sigma notation. So 3 reasons, like going green, faster, and also less ambiguity. However, the problem with sigma notation is that because it's a shorthand, some things are not immediately apparent to you because it's a shorthand. If you write something like in shorthand, when you read it, you don't understand why that is so, right? So I'm going to write down some properties of the sigma notation, and all of these properties will be obvious if you write the longhand, but it will be somewhat mysterious if you write the shorthand, okay? So let me write down the properties. A, if you have summation of I from 1 through n of C times AI, and by AI I mean AI is some number for each each I. So A1 is some given number, A2, A3. Let's say there are a sequence of numbers that's already given to you. Okay? And we're just denoting like that. Okay? The first property is that if you have a constant C multiplied to some sequence of numbers and you're adding them, that's same as C times summation of I equals to 1 through n of AI. Okay. Why is it so? Well, you just write down what it means and it should be apparent. Okay? So we're going to prove this. We don't do much proofs in this class, so you might be nervous when I say proof. And I'm writing the proof because I do want you to learn this proof. It's important that you understand this proof, because once you see the proof, you understand what it means, and it should be obvious to you, right? How do you prove something equal to something? There are several strategies. One will be like you start from the left side, write it out, and see if you can modify so that it looks like the right side. Another way would be write down what this means, and see if they're equal. That would be another way. There's still other methods, but let's just confine ourselves to those two strategies. Okay, so I'm going to write down what this means. All right, so what is I from 1 through n of CAI? Okay, what's the first term this produces? I equals to 1. I equals to 1 goes into I. So what do you read? C, A, 1. Then what does I become? 2. Remember, your I starts from 1, and whatever this number is, starts from this number and keeps adding by 1, right, until it reaches the top number, okay? So the next number is I equals to 2. 2 goes in here, producing what? C, A2. Right? And then you keep increasing I until you get to the end. So what's the last thing it produces? CAN. Now what does this sigma mean? Sigma is for summation, S, right? So you're supposed to add them, right? Okay. Now you see that all of these have C in front. So what can you do?
Factor C out.
You can factor the C out. And now let's see what this is. This is C times this, which is another summation, right? What are we adding? We're adding things that look like AI, where I starts from 1 and ends at n. Done. That's the proof. Okay? Now once you see the proof, it should be obvious, right? And why was it obvious? Because we used the longhand. Okay? We wrote down what it means. And once you write down what it means, then it's obvious, right? Okay. So for this next one, I want everyone to actually try proving it, because it really helps you to understand what it means. Okay, so B, I want you to try solving I from 1 through n of AI plus BI is equal to sigma AI, I from 1 through n, plus sigma I equals to 1 through n of BI. I just walked around and it's about 50-50. Half of you, actually more than half of you got it. I think like maybe 30% of you didn't get it. And I actually know who you are. You're the person who likes to buy a new gadget. Let's say you bought a chainsaw, right? Yeah. You open the package, right? And there's a manual. You throw it right to the trash, and then you work with the chainsaw, right? Yeah. That's the type of person you are, okay? And sometimes it works, right?
Wait, for the percent who like got it or didn't get it?
Who didn't get it.
Oh,
like, people who are not careful about these small details, okay? If you followed what I was explaining to the small details, you would have gotten it, because it's all there is. There is no previous material to know. All you had to do was listen to me, okay? You would also be the person who, if you get married, right, and your wife would say, "Why don't you listen to me?" You're going to be getting that a lot, okay? Because you need to be able to listen, right? That's the skill that all you need to do is to be able to listen to what it's saying. Okay? And if you did, then you would get it, right? So try to change your ways, because this is not about intelligence. It's basically your attitude about mathematics. Okay? You have to listen to what math says, and if you listen to it, it becomes obvious, and it's natural, and it's easy. Okay. So on the left side, so here's our strategy this time. I'm going to write down what this means. I'm going to write down what this means and compare the two. If they're equal, then these two are equal. Okay? So let's first write down what this means. Okay, what was the meaning of this again? You start with this number, you plug it in, and that gives you A1 plus B1. And then the next number is 2. You plug it in again. That's A2 plus B2. And then you keep going until you reach the last one, which is AN plus BN. And what do you do with these? Sigma means?
Summation.
Add them up. So that's what it means. Was that hard? It wasn't. If you were careful to listen, that was easy, right?
That's the answer?
No, that's not the answer yet. See, the problem is you are not patient enough, all right? It has more to do with the attitude rather than intelligence.
So it's not A1 plus, so it's A1 plus B1? I could A.
Okay, the next one. Let's see, what is this? You start from 1. 1 goes in, oh, not AN. 1 goes into I, giving you A1. Then this increases by 1, so it becomes 2. 2 goes into I, gives you A2. And all the way up until AN. And you keep adding. Done, right? But then there's a B, this the second one, right? And 1 goes into I, creating B1. The next one would be B2, all the way up till BN. So these are the longhand. Now all you have to do is compare them. Are they equal? Yes, it is. Right, isn't it? Because addition is commutative. It doesn't matter which order you add. You can add like this, or you can add only the A1, A2 until AN first, and then B1 through BN. It will be the same thing, right? So obviously these are the same, so that's the proof. Done. How's that? Simple, right? Okay. So I'm going to give you another challenge. Let's see if you can get it this time, right? So this third one, the last property I want to discuss is when I starts from 1 to n, and you're just adding c, where the c is a constant function. You know what a constant function is, right? No matter what you plug in for x, you get the same value. That's a constant function. So since there's no I here, this is a constant. So whether I is 1 or 2 or 3 or until n, it always produces c. Just produces c repeatedly, and you're adding them. Okay, so give me a formula that you're going to get if you did this. Great. So let me give you some time to do that.
How would we plug in the I if there's just a constant?
There's nothing to plug in. You will produce C, right?
Right.
You plug in 1, you get C. You plug in 2, you still get C.
Right.
Repeatedly, and then you end up adding them up. So that's what you write.
And C is always the same.
Always C.
When do you know when to stop though?
Until n. When it reaches n, you stop. And think about what that will be.
It's equal to C.
Huh?
It's the sigma the same.
All right. Okay, so let's try this together. Okay. All right. Can I have your attention? Thank you. So what does this mean? You have a constant c. So when I is 1, what does it produce? C. C is produced, right? And then what I becomes 2, you plug this in, what's produced? C is produced. And we're adding them, right? We keep adding them until I becomes n, and you're still adding C. Right? It's C, always adding C, right? How many times did you add C though?
As many times.
N times, right? So what is this? N times C. C is repeated n times, so that's it. Or I think people write Cn more. That's the formula.